Hi there, folks. I got a request for a couple of questions. These are quite advanced. Okay, they wouldn't be particularly kind of suitable for fifth years. They'd be more so towards when you get to do your leaving cert. These are really kind of leaving cert type questions. That's what you'll be getting. But I'm going to do them out because it was requested, so there's no problem there. So you're asked here to show that the maximum point on the graph of y equals to fx occurs at the point Euler's number over 1 over Euler's number. Okay. Now, so what we have here is we're going to differentiate that, right? And the maximum point occurs where dy dx is equal to 0. So if I take this function here, and fx is equal to the log of x all over x, okay? We're going to use the quotient rule here. So u is equal to ln x, and v is equal to x. So du dx is equal to 1 over x, and dv dx is equal to 1. But that's available in your tables book. That's one of the formulas that you're given in your tables book. Okay, so therefore the derivative, or f dash x, is given by v, which is x, by du dx, which is 1 over x, minus u, which is ln x, times dv dx, which is 1. And that's all over v squared, which is all over x squared. So simplifying that, that becomes 1, so it's 1 minus ln x all over x squared. Now, what you're going to do here is as follows. So you're going to let that equal to 0, okay? So you can say then 1 minus ln x is equal to 0 all over x squared. Cross multiplying 1 minus ln x will be equal to 0, and ln x is equal to 1. So ln, that's Euler's number. So if I put Euler's number in here for x, and you put into your calculator, so ln, Euler's number 1, it's equal to 1. So therefore ln is equal to 1. So therefore we know that the E number or Euler's number is equal to 1. Now, and then if you put into the original equation, so take what we put the original equation here. So I'm just going to give you some space here. We'll rub this out, and there we go. It's working there. So what I'm going to do is, because the x value is Euler's number, so I'm going to get f. If I put that into the calculator, so ln, if I put all that all over, that's equal to 1 over Euler's number. Just to show you that comes up as and that's equal to that, yeah. So that's how you do that one there. Okay, now it says here, hence show that the x to the power of Euler's number is less than or equal to Euler's number to the power of x. Okay, that's the second part of this question. And the way I'm going to do this is as follows, right? So this is why it's quite advanced. So if I get the derivative of each of these, okay, I'm going to get the derivative of each of these, and I'm going to show that neither of them have a max or min point, which means it shows they're a continuous curve. And then if you plot the curve and show, you'll show that this curve here is always bigger than this curve here. So that's how you go about doing it. So you get to show that no max min point, which means they're a continuous graph, and then that they draw up like this. And if you start them off on the line, they continue in that way, with one getting bigger than the other. So if we started off that y is equal to x to the power of Euler's number, then dy dx is equal to, okay, now, so what I can say there as follows, right? Now, if I let that equal to 0, because for it to be equal to 0, that's when it's going to have a max or min point. But there's no value of x I can put in there that's going to let that equal 0. So if you did, so I could divide everything by Euler's number, 0. There's no value I can put in there of x. Even if I put in 0, okay? Now, that's not going to work. Alright? So there's no value there, so therefore it's a continuous graph. And then I'm going to do the same for Euler's number to the power of x. Now, if you get your tables book, okay, the derivative of that is given by, so dy dx stays the same. And again, there's no value of x there that I can put in that will allow that equal to 0. So therefore, neither of them have a max or min point. Okay? So neither of them have max or min points. So now what I'm going to do is, I'm going to draw this out here just to show you, right? So we're going to draw a graph here like this. Now, and we're going to do 1, 2, 3, 4, 5. So we're just going to do it for 5. Now, I did do these out just to speed things up a little bit, okay? And the different values that we have. So I'm just going to write this up. 10, 20, 30, 40, and so on. So, the graph here, the first one I'm going to do a blue graph for x to the power of Euler's number. Okay? So, the first one is, it starts off at 1, then it's 6.5, it's around there, then it's 19, so it's just there. For 4, it's 43.308, so it's here. And 5, it's 79, so it's all the way up here. Okay? So I could draw a graph like that. And that just keeps climbing. That's that graph there. Now, and that's y is equal to x to the power of Euler's number. I'm going to do the next one now in red. And this is the Euler's number to the power of x. So it starts off, it's at 2.7. So we do that there. Then we have 7.389. Roughly there. 20, oh, that's then for 3, it's at 20 point there. For 4, it's 53 there, and that keeps rising up. So and that keeps going up like that, right? So at every point here, whatever your value is, okay, if you were to draw lines down, look, say I wanted for at 3.5, well then, that one there is bigger than this one here. The red is bigger. That's just a rough graph, but gives you an idea of how that works. So that's how you do that question. As I said, that's quite advanced, but just to understand that and to do continuous functions. Okay, now, the next question then. This is a really tough calculus question. This is a classic Leaving Cert 50 mark exam question. Okay, so we start off with part A. So you're given a vessel in the shape of a right circular cone is placed, so it's standing on its apex. The water is flowing into the cone at a steady rate of 1 meter cubed per minute. So what we need to remember first of all is that's volume filling up per minute. So it's the rate of change of volume with respect to time. So that's known as dV dt. The vessel has a height of 2 meters and a diameter of 2. Okay? So using similar triangles. So what that means is, so say for example, I was to draw a triangle like this, right? And we'll do a 90-degree triangle like this. Actually, we'll do it this way here. There. Now, if you imagine that's my cone. There. Right. There's our triangle there. Now, it says here, right, that the radius is 1, the height is 2. So that's the radius, that's the height. Okay, now, what you have to remember is this. If I put an angle in here, I can say that tan theta is equal to opposite over adjacent, which is equal to 1 over 2. Okay, now, if I was to draw a line then across, we'll say a line here, like that. Now, what you'll notice is, this angle doesn't change. So therefore, tan theta is the opposite over adjacent, has to be the same ratio. So the opposite over adjacent is equal to the radius over the height. And that's equal to 1 over 2. So no matter where I put this line, look, if I put another line, say here, look, that angle stays the same. That's opposite and that's the adjacent. So basically what you can say is, because of this angle here and because of tan, that the radius over height, because the radius is the opposite side and the adjacent is the height, okay, is at 1 over 2. So then, therefore then, I can use this to say, so you want to show that the radius is equal to half the height, okay? So if the radius over h is equal to 1 over 2, well then I can say that the radius is equal to h over 2, which is a half h, okay? So now we know that the radius is a half h. So that's that there. And then it says show that the volume of water. Okay, so we've shown that bit there. So now what I'm going to do is just delete this bit here and we'll see. Just delete that there. Okay. So it says then, show that the volume. So volume is given by 1/3 pi r squared h. Now we know r is equal to half h. So the volume is equal to 1/3 pi h over 2 squared times h. Multiplying that out, I get half of pi times h squared over 4 times h. Sorry, it's a third. Half, that's a third. So 1/3 times 1/4 is 1/12. So that's going to give me 12 times pi, h squared times h is h cubed. That's what we're looking for here. Okay, so that's the first part of that question. So again, look, I use this part here, radius is half of h, and I subbed it in instead of the radius. H over 2 squared is h squared over 4, and then I multiply that. H squared times h is h cubed. I actually wrote that wrong there. It's pi h cubed there. Okay, and then a third times, so that's that there. Okay, now it's part B that so again you can see there that a lot of that is manipulation of formula, and manipulation of formula, as I've said already in the classes, how important it is. Okay, and I have done a lesson, and it's something that you need to keep practicing all the time, especially for the higher level. It comes up quite a bit. Okay, now so the next part there is when the vessel is 1/8 full. Now, when it's 1/8 full, that's the first part you need to look at, okay? When it's 1/8 full. So we need to figure out what its radius is when it's 1/8 full, because the rate at which the water is rising, that's your height, or dH dt. So what you've been asked to do here is that's dH dt. And the rate at which the free surface that the water is increased. The free surface is the top of it, so that's the radius, okay? So that's dr dt is what you're looking to get. Now again, as I said, this is quite complicated. This is quite advanced, so it is, right? So don't worry, see if you can figure it out, but don't be worrying too much about it. Now, when the vessel is 1/8 full, so in order to find this, you need to get the radius when it's 1/8 full and the height. Okay, so we've got this where r is equal to 1 and the volume, or the height is equal to 2. And the height is equal to 2. So the volume is equal to 1/3 pi r squared times height. So it's equal to 2 pi over 3. That's the volume of that. Okay? So that's what our volume is. And even if you put that into this formula here, 2 cubed is 8, 8 over 12 is 2/3. Alright? Now, when it's 1/8 full, okay? So when it's 1/8 full, so the volume when it's 1/8 full is going to be 2 pi over 3 times 1 over 8, which is equal to pi over 12. Okay, so it's pi over 12. Now, what's the height when it's pi over 12. So what you do here is this. So the volume is 1/12 pi h cubed equal to pi over 12. Because that's the volume when it's 1/8 full. And this is the formula for the volume. So if you notice here, watch. Pi cancels, that cancels. So the height is equal to 1. So when it's 1/8 full, the height is equal to 1. So when it's 1/8 full, the height is equal to 1. And also we know that the radius then is equal to a half. Because the radius is half the height. So when this vessel is 1/8 full, the height is 1 and the radius is a half. So this is with a question of this, you have to do it in different parts. And you'll see why I've got this now when we come into it, okay? So that's what we need to remember, right? So when it's 1/8 full, so I'm just going to write this to remind me because this is the next part of the question we're going to go into. This is the calculus part. So as I said, it's a complex question. There's a lot of parts to it, and you have to segregate them. So and use the information from different parts. So when it's 1/8 full, we know that the height is equal to 1 and the radius is equal to a half. Okay. Now you're asked to you have to find the HDT. So in order to get the HDT, okay. So the HDT. Okay, I have a formula. I have here, up here. That's known as the VDT. Because I have no formula that links height and T, a formula that has H and T in it, that I can differentiate. What I do have is I have a formula that links V and H. Okay? So what I can do is, I've got the VDT. And if I multiply that by the HDV, what happens here is, look, the DVs will cancel, leaving me with the HDT, which is what I want to get. Now, I have the VDT, it's equal to 1 meter cubed. But I don't have the HDV. So, this is how I go and get that. So the volume is equal to 1/12 pi h cubed. The VDH is equal to 3 times 1/12 is a quarter, so it's pi h squared over 4. Alright, so that means then that the HDV is equal to 4 all over pi h squared. So therefore, the HDT is going to be equal to that multiplied by 1. So the HDT is equal to the VDT, which is 1, times 4 over pi h squared. Now, we want to find this out, okay? We want to find out because when it's 1/8 full, h is 1. So I put 1 in here. So therefore, it's going to be 4 all over pi. So the height is rising, the water is rising at 4 over pi centimeters. Meters per second. That's that there. And now, so the free surface of the water is increasing. That's just going to be for radius. Okay? So you're just going to do that then for radius. So instead of your formula, so you do the whole thing again, and instead of your formula for h cubed, okay, you're going to put in what? So we know that. So just looking at this here now. So it's the same process that you try and do for the radius, because it's the area. If you look at that, so it's when this is getting bigger. So what determines when that gets bigger? It's the radius. The radius gets bigger each time, right? So we want to find out the dr/dt. That's what we're looking to get. Okay, so I need a formula for dv dr. So basically, I know that from up here that r is equal to half h, or I can say that h is equal to 2r. So you can now say that the volume is equal to 1/12 pi. So instead of h cubed, you put in 2r cubed. 2 cubed is 8, so it's going to be 2/3 pi r cubed. So that's v. So now I can get the v dr. If I want to get then, so in this case here I need to get the r dt. dr dt is equal to dv dt times dr dv. So you get dv dr, which is going to be equal to 3 times that, so it's 2 pi r squared. So it's 1 over 2 pi r squared. So it's going to be 1 times 1 over 2 pi r squared. And the radius when it's a half, because we know here it's a half, so it's going to be equal to 1 over 2 pi times a quarter. So it's 1, so it's half, so basically it's equal to 2 over pi. That's how you work that out. Okay, as I said, that's a complex question, right? And that's a real advanced leaving cert question that could easily come up, right? But it's not something, so for a 5th year student to be attempting this is brilliant. Very far ahead, okay? So if you have any queries on that, just send me an email. I hope that kind of explains it and that you understand it. But if not, just send me an email and I can send you back another video just explaining a bit more. Okay, thanks guys.